What about the other tracking stations in Europe? Surely there would have been an interest in identifying
Hello guys,
Soviet
welcome back to
launches by
another
entities
fucking
that
video,
must
and
have
in
thought their
today's video we're
equipment
going to
their
be playing
amateurs. So
some
why
more
did no one else pick up any of this?
motherfucking
When we
VG.
examine the claims
So
by the
anyways, yeah,
Utica
let's
Cordiglia brothers in
get into it,
totality, we are left with no
I
choice
guess.
but to conclude that many or all of their reports are falsified. While the recordings do warrant consideration, the conflicting evidence as well as lack of corroboration is enough for me to conclude that these recordings are, in some way, illegitimate. Many of the people who argue in favor of these last cosmic theories talk about the intense secrecy of the Soviet Union. They have a tendency to say these missions were simply covered up and that references to them were erased. In some sense, this does seem plausible. In fact, there are some known major Soviet failures that were hidden. For example, the 1960 Magellan catastrophe was an explosion on a launch pad that led to dozens of casualties. It was not admitted by the Soviet Union until 1989. Other cover-ups include the death of the cosmonaut trainee Valentin Bondarenko, which was concealed until 1980. These examples might make it appear logical that there were other failures that were suppressed. However, the key difference between events like these and the Utica Cordiglia recordings is that extensive evidence eventually did come to light. But this is yet to happen with the Utica Cordiglia claims. Beyond what we covered here, there has not been any explicit evidence besides the occasional quote. No written records, no photographs, nothing but a few short recordings that apparently came from space.
Stop.
Sven Gran, who's been referenced a few times already, has a quote that really crystallizes the situation. Extraordinary claims require extraordinary evidence to be believed. Many of the brothers' claims were certainly extraordinary, that the Soviets were covering up failed human spaceflights, that Gagarin was not the first man in space, that Tereshkova was not the first woman. Yet, the extraordinary evidence necessary to believe such claims has yet to make itself known. It's worthwhile to mention that the brothers continue to stand by their reports, even in later interviews, and it does appear as though they went to lead on respectable careers after they ceased operations at Dorebert. Bekele died in 2015 after a career as a cardiologist and later a philanthropist. Giambattista became an audio and photographic expert at the court of Turin. And despite the tenuousness of some of their claims, it's likely that they actually did have a functional tracking station, and were at least able to pick up some transmissions. But for whatever reason, many of their reports do not stand up to analysis. Before we conclude, let's take a quick look at the sponsor who made today's video possible. I want to talk about today's video sponsor, Bespoke Post. It's a monthly membership club delivering boxes of top-shelf goods. Each box of awesome has around $70 in value, but you only pay a fraction of the price. 90% of the products in Bespoke Post boxes come from small brands, many of which are based right in the US. You get a box assigned to you each month based on the quiz you take when signing up. For example, let's say I'm not very interested in barware and mixology, but I'm open to trying home decor and accessories. I'm very interested in camping and outdoors. Bespoke Post recommends boxes that I might like to receive. In my case, I was drawn to the Explore box, the Grounds box, and the Retreat box. Explore had several items, including a collapsible backpack that will be really useful for day trips. Grounds is great for camping, including a very convenient inflatable seat. Finally, Retreat contained a hammock and a blanket, perfect for relaxing at the end of a long day of hiking. Before each box is shipped, you get a preview of what comes inside. You can decide to keep it, swap it for a different box on offer, or skip the month entirely for absolutely no charge. You only pay for what you want. To get 20% off your first box of awesome, click the link in the description and enter RetroGamingNow20 at checkout, or go to bespokepost.com/RetroGamingNow20. Thanks once again to Bespoke Post for sponsoring the video. I want to thank you all for joining me for this video. It's a little bit different from stuff I've done before, and I hope you enjoyed it. I've done my best to present a fair and accurate representation of the reports of the Utica Cordiglia brothers. However, it is possible that I have made mistakes, so I'll do my best to write any sort of corrections in the description. Furthermore, I was unable to cover everything. If you dig deeper, you'll certainly find stuff that I didn't have time to mention, such as the brothers' 1964 trip to the United States, their discovery of radio codes indicating Soviet launches, or the KGB agent that apparently confronted them at their home. Additionally, others have done more detailed analysis on the climate which led to these claims taking off. And of course, this is just one small part of the larger story of the space race. If you enjoyed this video, feel free to subscribe, and let me know what you think in the comments. I really appreciate your feedback. We'll go ahead and end with that. This has been RGN. Thanks so much for watching, and I'll see you all in the next video. Have a great day.
McCormick notes unbeatable flavor. So we created Flavor Sealed, so spices are as fresh and flavorful as the day they were packed. Letting you make know without everyone licking their chops. McCormick, Flavor Sealed for unbeatable flavor.
Do you know the many surprising connections between the deepest parts of space and the deepest recesses of our ocean? Both are cold, dark places where humans cannot breathe and where the pressure alone is enough to kill you. Both upset our normal experiences of gravity, providing explorers with a strange weightlessness or buoyancy if they could somehow survive being there in the first place. And both contain many unsolved, captivating mysteries. Our oceans are filled with life we've never seen before. And who can say what lurks in the unexplored corners of space? I was initially caught off guard when I heard that NASA had turned its attention towards exploring the hadal zones deep in the ocean. After all, NASA is normally about space. What are they doing deep under the water and on Earth? I'm Alex McColgan and you're watching Astrum. Put on your diving gear and join me in a world of undersea facilities, uncanny life, and an environment so hostile we've mapped more of Mars than of this terrain
Motherfucker.
on planet. In 1957, a year before NASA was founded, a paper published by the Journal of the Royal Society of Arts claimed the deep oceans covered over 2/3 of the surface of the world, and yet more is known about the shape and surface of the moon than is known about that of the bottom of the ocean. This was a reference to the fact that in the world before echo-sounding technology was commonly used to map the seafloor, we didn't know much about the topography of what was down there. We've come a long way since then. But while we have mapped the moon thanks to satellites and telescopes, we have still only mapped 23.4% of the ocean floor in high resolution. In fairness, this still represents an area of 120 million square kilometers, about 3 times the moon's surface area, so the old saying no longer holds entirely true. Hence why Mars, which has a surface area of 145 million square kilometers. But still, it's a profound gap in our knowledge of our own world. NASA was founded in 1958 with the purpose of expanding human knowledge of phenomena in the atmosphere and in outer space, and developing vehicles and technologies that would help them to do so. Exploring the ocean was not originally on their radar, or sonar. However, in 1978, NASA began monitoring the ocean with their first dedicated oceanographic satellite, Seasat, which was capable of collecting data on sea surface winds, surface temperatures, wave heights, and other features. This helped them learn more about our planet's oceans and their impact on the global climate. Still, some of NASA's most exciting forays into the ocean only began at the turn of the millennium. One way in which the sea can prepare astronauts for space is through simulated space experiences. About 8.7 kilometers off Key Largo in Florida is the world's only undersea research laboratory, Aquarius and Reef Base. Built in 1986, it is a small, 3-roomed habitat large enough to house 6 people at a push, with a main room that combines sleeping and living quarters, an entry dock, and a wet porch for entering the sea around it. It was originally designed to help aquanauts remain at the bottom of the sea for weeks at a time, through a technique known as saturation diving. By remaining at a depth of 19 meters, the human body becomes saturated with gas dissolved in its bloodstream, which allows these researchers to stay at depth without ill effects for much longer periods of time, 9 hours for one dive, rather than 1 or 2 hours. This made it ideal for biologists wanting to study the local environment in situ. In 2001, however, NASA, along with other space agencies such as ESA, realized that it made a great space training location. The current living conditions mimic those found on the International Space Station, so astronauts who spent a week at Aquarius Reef Base would get a vital taster of what life would be like up there. It also allowed them to practice performing experiments and generally get used to the expected and unexpected aspects of life in a hostile environment. NASA began the NEMO program, or the NASA Extreme Environment Mission Operations, and that same year began sending their astronauts to the habitat. There have been 23 NEMO missions since then, merging astronaut crews from a variety of different space agencies, which lasted up to 3 weeks. Astronauts then became astronauts and got the chance to don deep spacesuits, getting a taste for what spacewalks might be like outside of our planet, readying them for the day humans return to the moon or go to Mars. This was not the only use NASA had for the ocean, however. Perhaps the most significant training was not for NASA's astronauts, but rather for the machines that would one day visit the largest oceans outside of planet Earth. Let's now go deeper and consider the exploration of alien oceans. Our solar system is home to many large oceans outside of Earth. Jupiter's moon Europa and Saturn's moon
Dude, I don't have a bank
Enceladus
account,
too,
dipshit.
significant bodies of water beneath their kilometer-thick icy surfaces. In spite of only being 1/4 of the Earth's diameter, scientists believe that Europa holds twice as much water as all of our oceans combined. This is an intriguing concept, as even though no sunlight penetrates down to those depths, the mixture of
No,
liquid
that's
water
Optimus
covering
Bob.
the rocky inner crust would make both of these locations ideal candidates for life. Scientists have considered how to best test to see if life really has arisen in the oceans of icy moons. In 2024, NASA will launch the Europa Clipper with the mission to fly by the moon Europa and scan it to learn more about the depth of its icy shell, to try to determine the composition of its oceans and generally get a better picture of the moon as a whole. However,
I didn't wanna
the
think
Clipper will
not.
be laying the groundwork for future missions, which one day might see cryobots melting through the 10-kilometer thick icy shell of Europa using nuclear-powered radiators to penetrate its oceans and see firsthand what lies below. Once down there, our radio signal will be able to reach them easily. Messages will be relayed via a vast cable brought down through along with the cryobot. This means that such cryobots will need to be able to autonomously descend over 100 to 200 kilometers to explore the dark, chilling, and highly pressurized environment they're likely to find, to see what alien life might swim in those waters. So, with a mission objective on the horizon to explore deep, dark waters in search of never-before-seen life, what better place to start
What?
than the unexplored oceans we already have at home? The deepest parts of the oceans on Earth are only 11 kilometers deep, but due to the gravitational differences between Europa and Earth, the pressure you'd experience between the two are much more comparable than you might think. Europa's 100-kilometer deep ocean is thought to have a hydrostatic pressure between 130 to 260 megapascals, which, if it existed in an ocean on Earth, would have a depth of around 13
What
to
the f did I
26
just do?
kilometers.
What the
This is much further
f?
to go hundreds of kilometers down on Earth, but it's still no picnic. Pressure at the bottom of the Mariana Trench, the deepest place in our ocean, is 1,100 times the pressure on the surface, which is enough to crush the individual cells in the human body, or to implode most submarines. And yet, life survives there. And it doesn't just survive, it thrives.
If your grandpa wears one of these, or if your wife wears this, you can count on USAA. Membership for the spouses, kids, and then grandkids of those who served. Count on us. Count on USAA.
Fuck you.
The Tempur-Pedic Adapt mattress eases your pressure points in a way no other mattress can.
Copilot, create a dreamy podcast about living on Mars.
Today, we're diving into life on Mars.
Here's something that'll blow your mind. Mars gravity is about 38% of Earth's.
Copilot, what should we explore next?
Bruh.
Get a large two-topping Crazy Crust pizza for $6.99 from Little Caesars. Pizza, pizza.
The deep sea.
Gallery. I know I have a screenshot. It's definitely not that far back. Oh, then, or actually, yes, it is this far back.
explorers of the Galapagos hydrothermal expedition in 1977, using a specially reinforced, remotely operated vehicle that could survive those pressures, were shocked to discover not a barren wasteland, but thriving ecosystems gathered around hydrothermal vents in the ocean floor down there. Tube worms, crabs, and fish were found in rich abundance. As scientists performed more dives, they found all manner of strange life forms down there. Shrimp like amphipods the size of your hand, giant, ethereal, big fin squid that were 8 meters long and looked positively alien. In the depths between 6,000 and 11,000 meters, in an area known as the Hadal Zone, named after the god of the underworld, Hades, life had learned to adapt to conditions in ways no one could have imagined possible. And this incredible adaptability gives scientists a better understanding of what might be possible on other worlds. The deepest parts of the ocean are mostly found near the fault lines of continental plates, where one plate subducts under another. These deep trenches create a unique V-shaped environment that channels organic debris from above down into a sludgy pool. Whenever a carcass falls down there, the organisms in the Hadal Zone are somehow able to quickly detect it and arrive within minutes. Other organisms rely on nutrient-rich liquids pumped out of thermal vents. If you added up all these trenches into one landmass, you would end up with an area the size of Australia, a whole unexplored continent. NASA wants to explore these regions using autonomous drones, perhaps whole swarms of them that will be able to detect locations of interest such as thermal vents, and will be able to map out the terrain using cameras and onboard AI, similar to that used by the Perseverance rover on Mars. It's a challenging task. Not only would such a drone need to be able to withstand the excessive pressure, but the temperature around such thermal vents can spike to hundreds of degrees. Drones would need to be able to survive rapid temperature swings if they are able to survive. In 2014, one such deep-sea drone known as Nereus was sent into the Kermadec Trench off the coast of New Zealand. This is the area NASA has selected as testing ground for its new equipment. However, sadly, Nereus was not able to survive the pressure down there, in spite of having succeeded on Hadal dives before, and it imploded. Pieces of plastic were later found floating to the surface. NASA's latest drone is Nereus's descendant.
You mean it imploded, not exploded? Unless you said that, I'm just a fucking dumbass.
Instead, it is being put through its paces in shallower waters. But it works. Its lighter design would make it easier to transport on a rocket to the oceans of Europa at some point in the distant future. Although, this dream might not be so distant after all. In 2023, NASA's Planetary Exploration Science Technology Office gathered a team of 40 top researchers from multiple fields in the California Institute of Technology to discuss how close we might be to making this trip. A surprising amount of technology needed is already there. Their conclusion was that the mission was feasible, scientifically compelling, and the most plausible near-term way to directly search for alien life in situ on an ocean world. With the combined information being gathered by Europa Clipper and the technical experimentation being done with Orpheus and other autonomous submarines like it, perhaps it is something we will see within our lifetimes, although no concrete plans have been made yet. When it finally does happen though, and a human-made drone starts to swim in those dark seas across the Gulf of Space, what will it see? Perhaps it will feel strangely like home. We are water-based life forms here on Earth. The first large, complex animals formed in our oceans. All life is dependent on water to live. Rather than
well, really, I wouldn't say the first, or never mind. I don't even know. I don't fucking know what I'm saying. Don't.
Entering a place we already know.
Don't ask.
Even though we've never been there before. Does something lurk in those alien seas? Although it's only speculation, the sheer fact that this might be true is enough. to discover that life came to exist not once, but twice in just our own solar system would have massive implications on life's prevalence in the universe as a whole. It would mean life is likely abundant, and we ought to be ready to see a lot more of it out there. But proving it is the challenge. Only by perfecting the technology here on Earth will we be able to crack open those frozen shells, enter those inky depths, and find the definitive answers we seek. For NASA, their mission to find life in our solar system begins in our oceans. Take a walk with me through an ancient, verdant land. So vivid are the colors and aroma of the entangled fauna that it takes you an age to notice something isn't as it should be. It's all quiet. The near absence of birds and mammals is the only indication that this land is dying. Its fate sealed by the ending of an ice age. Waters are rising. The lush landscape below your feet will soon be 30 meters below the surface of the Pacific. Any species able to migrate have escaped to continue their fight for survival in a warming, shrinking world. Those given life by their roots are held to perish by them. What is happening here? What can we learn from the history recorded deep in the melting polar ice is of vital importance, because right now, it's happening again. What is causing the ice caps to melt in the present? How will it affect the most powerful...
God damn it, who broke my TV?
What dangerous does the ice contain? I'm Alex McColgan, and you're watching Astrum. Join me today as we look at what
Same motherfucking video, 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 same mother...
On Astrum, we love to explore gigantic objects in our universe whose scale through time and space stretch almost beyond our grasp. Look up towards Cassiopeia, and there is our closest galaxy, Andromeda. 2.5 million light years away, 200,000 light years from edge to edge. Yet, despite its magnitude, we can connect to it. So it's curious to me that looking only 80 years to our future feels too distant to connect with, to understand that things we do today affect tomorrow's world. So, let me take you there. At the beginning of our journey is the ice. Ice is a remarkable substance, one that can store vast amounts of energy. As a comparison, energy stored in modern electric cars, capable of accelerating tons of metal to over 160 kilometers per hour, and carry both it and you hundreds of kilometers, could scarcely melt ice that would fit on its back seats. The energy storage capacity of ice is a large part of the reason that the climate has been so stable for the past 12,000 years. The ice is acting as a buffer against extreme temperature rises and falls. The Holocene has been a unique period in Earth's history for another reason too, the rise of human civilizations, made possible through the development of agriculture.
Petco's always been where the pets go. For the brands they can't get enough of, expert hands-on care, and to live their best life. Celebrate 60 years with us in stores and online today. Petco, where the pets go.
At Ross, magic is turning the find into a show-stopping luck. L tampons are gentle and powerful, made without synthetic pesticides or fragrances, and powerful all-day leak protection.
God, fuck it, fuck you.
Choose L and choose love.
What does hassle-free nicotine satisfaction give you? The endless possibilities of right now. Because you don't just find freedom, you keep finding it. Warning, this product contains nicotine. Nicotine is an addictive chemical.
If it feels like your phone hasn't changed in years, maybe it's time to change your phone.
Antarctic ice cap first formed around 37 million years ago. The Arctic, 2.7 million. As old as the light reaching us from Andromeda.
Bro really called me the N-word.
Important for our stable climate
Wap.
today. Their historical size has largely been defined by Earth's position and tilt in the solar system, movements that affect the amount of energy that our planet receives. These movements are known as Milankovitch cycles, which I have covered in a previous video. According to these cycles, the ice at the poles should be increasing. We should be heading into an ice age. The sea levels should be falling as the ice caps get deeper. But instead, the polar ice is melting. Massive amounts of energy are being absorbed by the caps. And are going in the opposite direction that the Milankovitch cycles predict. The ice loss is accelerating. Should all the ice melt, we are facing a 70-meter sea level rise, which will flood all coastal cities on the planet. Fortunately, that degree of ice loss is exceptionally unlikely, but we do need to know how much sea level rise to expect so that we can plan ahead and protect Earth's ecosystems. To predict just how much, we need to understand why and how the ice is melting. We know the release of greenhouse gases is a driver of today's global warming, overpowering the Milankovitch cycles, causing the ice caps to melt and the sea level to rise. But I was astonished to find out that this hasn't always been the case. Detailed records kept in the Antarctic was increasing temperatures that caused increasing CO2 levels. Cause and effect were flipped. But isn't that a blatant contradiction? Well, actually, no. Each positively influences the other. It's just a case of which happens first. We see this play out as the increased temperatures of today's climate thaw the permafrost around the Arctic Circle, releasing long-stored carbon reserves, which in turn accelerate further global warming. The mechanism by which increased CO2 and temperature affect the polar regions reveals a complicated and fascinating climate system.
It's not fascinating, it's horrendous. It's fucking... We're killing the Earth.
This heat is retained by the atmosphere and the ocean. Around 90%.
I feel like I'm the last person to be fucking talking about that.
Surprise, given it is almost 250 times the atmosphere's mass. So, where does this extra energy go?
Why the fuck is that so... Oh, that's why.
Or licked a ski lift chair knows, heat moves from hot things to cold things. So it makes sense that it is at the cold poles where we see many times the average global temperature increase, because that's where the temperature gradient demands that the energy flows. And it's flowing there primarily through the ocean currents. Because of its density and heat capacity, water is very effective at transferring energy. That's why water is used both as a coolant in cars and a heating medium in homes, and why air with a low density and low heat capacity is often used as an insulator. That difference allows you to sit comfortably in a 90°C sauna for many minutes, while you'd reflexively be unable to insert past your fingertip into water of the same temperature. Other factors play a role in melting the ice too, like the albedo or whiteness of the ice. Soot darkens the surface of the ice, causing it to absorb more energy from the sun. Air quality measures are reducing particulates in the atmosphere and on the ice, meaning we will see less melt from ice directly absorbing the sun's energy. But the lowering of particulates in the atmosphere also blocks less sunlight overall, so more energy reaches the surface, accelerating the greenhouse effect. I told you it's complicated. Let's explore the ways the oceans are melting the polar ice, as it is happening right now on the West Antarctic ice shelf, a particularly vulnerable area. It contains ice in several forms. Sea ice is very seasonal and is responsible for the doubling of Antarctica's area through winter. This ice melts through contact with the ocean as ice cubes do in a cocktail. The direct impact of all the sea ice melting would only contribute a few centimeters to sea level rise, but its importance lies in its role as a barrier to the otherwise exposed ice shelf. The sea ice insulates the oceans from atmospheric warming and keeps the humidity and temperature of the air above it low, being fresh and white, like the most fairy tale of glistening winter flurries. It also reflects a large portion of sunlight back into space. When this sea ice is low, it exposes the ice shelf, which protrudes almost all the way around the Antarctic. These floating ice shelves can be gigantic. Some, like the Ross and Ronnie Filchner shelves, are greater in area than my home country, the United Kingdom. The warm sea water seeps inside of the shelves. Huge icebergs the size of
There has to be like
can break away as it weakens and drift as far as Africa. Since these ice shelves are melting, they also contribute minimally to the rising sea levels. But it's what the ice shelves hold back that has the most potential for sea level rise. As the shelves shrink, the main body of sheet ice that sits atop land is more exposed, allowing faster flow rates from glaciers and ice streams. But don't be fooled, these ice streams are far bigger than their name would suggest. Incredibly, some are as wide as the mouth of the Amazon, hundreds of kilometers long and kilometers deep, all flowing towards the sea. Feeding these streams is the colossal ice sheet itself. Since the ice sheet is supported on land, the mass of ice melt leads to a direct increase in sea level. These ice melting processes are natural phenomena and would still occur without global warming. The poles take fresh snowfall and ice formation every year, which adds to the mass of the ice. And just for them to retain their current size, we would witness sea ice melting, ice shelf carving, and glacial flow. Although, at this very moment, Earth's polar ice sheets are far from equilibrium. The rate at which they are losing ice is quicker than fresh snow can fall, meaning that they are shrinking. Because of the extra energy in our oceans and in the atmosphere captured by greenhouse gases, we are already committed to significant ice sheet loss. Can we say how much sea levels will rise from the melting alone? If you thought it would be a simple case of calculating the volume of ice lost and adding it to the volume of water in the seas, well, you can join me in being wrong. To arrive at an accurate estimate, we need to understand a few other interactions. We tend to think of Earth's crust as solid, but given enough force, the Earth will change shape too. As the ice melts, the continental plate that supports it bears less weight and rises up above sea levels, while at the equator, the coastal land shrinks into the sea, creating localized sea level falls and rises. But the single biggest addition to sea level rise to date required no additional water, and was simply due to the thermal expansion of what was already there. Around half of the sea level rise we have already seen since the Industrial Revolution has been due to this expansion. This process is easy to calculate, and we know how it will contribute to sea level rise in the future. However, the deluge of cold, fresh water being dumped into the salty sea has other, less predictable consequences. Remember, Earth's systems are dynamically intertwined. A feature of these dynamic systems is that they are vulnerable to dramatic changes in behavior, known as tipping points. As with playing Jenga, the tower becomes less and less stable as we mine the lower levels for material to build each.
Destiny has its first mobile.
Fuck you.
Nearly touching the next brick brings it crashing down. This would cause a very rapid phase change. One tipping point that could occur within our lifetime is the slowing of the Atlantic meridional overturning circulation.
Yo, I love how we
This is an oceanic
fucking
flow, a
no,
powerful
recognize
energy
that the
transfer system. Should it weaken or collapse completely,
recognize that that
sea levels on the
so
eastern
that the
seaboard of
one time
America
that the
could
fucking
rise by up to 1
ozone
meter.
layer or whatnot had a fucking hole in it,
Coastal waters will
and then we reversed it.
However, Europe
Only
will face other,
to
more extreme
nowadays fucking reverse that reversal.
Patterns would change drastically, pushing some ecosystems to become rainforests, while pushing
We're dumb.
others towards desertification.
We're fucked. Yeah, we're dumb and
To
fucked.
understand how all of that is possible, let's look at how the AMOC functions. Haline circulation system. It is driven by changes in heat, thermo, and salt concentration, haline. The AMOC brings warm tropical waters up past the United States and across to Europe, helping to make Northern Europe warmer than it ought to be, considering its proximity to the polar circle. As these waters it is partially frozen into sea ice.
What?
You awake?
No.
You were still half asleep when I left, so I thought I'd, ask. I tried texting you, but I got no response, so. Are you hungry? I can start your food here after I get mine.
Yeah.
Oh, sick. Maybe.
Yeah.
Okay.
Love you too.
Keep your fingers crossed for us. We got another potential place to put Grandma. The other one's backed out on us. This one maybe, hopefully, sounds promising.
What?
Love you.
Love you too.
Which leaves cooler, saltier water to sink to the bottom of the ocean, where it then flows back south to complete the cycle. However, the melting of the Greenland ice sheet is inundating the northern part of the AMOC with fresh water, diluting the seawater, making it less salty and less dense. This makes the gradient directing the water to sink to become shallower, slowing down this part of the cycle and reducing the flow. Just as a slow middle lane driver on the motorway can cause lag, stretching frustratingly back across all lanes. The slowing down AMOC backs up water on the American East Coast and reduces the flow to Europe, meaning that sea levels would rise in America while Europe would be spared. Though that's a little consolation to a continent that will lose
I mean,
its way of
we are the
and
fucking worst.
production capacity through cooler temperatures. The UK alone is facing an average temperature drop of 10 degrees Celsius, which would make it colder than Iceland now. The melting Greenland ice sheet also contains organisms living on Earth for hundreds of thousands of years. When a new predator travels to an ecosystem not prepared to live with it, it can upset its delicate balance. This is also true of a pathogen the species would all be harmless, but as we saw in 2020, it takes one black swan to change everything. With more cells being released from ice melt each year than there are grains of sand on Earth, the risk one is a black swan is significant. A risk that increases with the depth with the permafrost thaw. The further back in time the potential pathogens from, the bigger the jump in its genome, our ecosystem's readiness for it. So, the world is changing. As we have seen, ice is an incredible recorder of Earth's history. Through studying its secrets, we can see Earth's past. Just as the ice caused Earth's ecosystem as the Strait flooded, it contains our history too. As the ice melts, it replays many of humanity's environmental missteps by re-releasing trapped chemicals we have produced. CFCs stored in the ice can again deplete the ozone and accelerate Arctic ice loss. Chlorinated pesticides, many long banned from use, can find their way back into Earth's ecosystem, some of which will have been made even more potent by their time stored in ice. Vaporized lead from the use of leaded petrol will also be re-released, as the ice layers that contain it melt away. This chemical cocktail adds yet more stress to a global
God
ecosystem.
fucking damn it.
Also be re-released as the ice layers that contain it melt away. This chemical cocktail adds yet more stress to a global ecosystem moving ever closer to an invisible edge. When we add all these factors together, the year 2100 could look very different. Exactly how different is...
Will you stop fucking lagging? Now. God damn it.
Sound like much, does it? A map of the world's coastline. Well, the current average sea level rise is 0.5 meters. It doesn't sound like much, does it? A map of the world's coastlines would look almost unchanged. However, it's not averages, but it's not floods, the heat waves drive human behavior. In the year 2100, a population the size of the US will be exposed to regular coastal floods. Faced with increased risk, where will Earth's coastal populations move to? How much will our way of life change?
This is a meal, a tender Italian steak and so good you can't stop saying focaccia meal. Focaccia. 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 Focaccia.
Focaccia.
Focaccia. Try the new Italian steak and meat sandwich. It just feels good at Panera. This is Buick, now. Buick, exceptional by design.
Get 0.9% APR and no monthly payments for 90 days on these 2025 Buick models.
Meeting the BXD and PXP with the L4 BMG from B cabs.
What? By G? Does that shit fucking say by G cubes, or am I going insane? Can somebody please tell me? Don't know. Just tell me in the comments or somewhere. Preferably the fucking Preferably the fucking comments. Do you want to exchange? Oh, man, I fucking forgot what exchange means, bro. That's fucking just sad. What does exchange mean? Oh. No, never mind.
To align with the JPKs from GDC.
The rich diversity we see in cultures and species on Earth is born out of adapting to the environment. Both humanity and life itself have demonstrated time and time again that they are irrepressibly adaptive. Humanity can and has to learn from its past and look to the future. So, there is hope. While the melting ice reminds us of the environmental damage we have been responsible for since the Industrial Revolution, it also reminds us how often we come together to make a change for the better when we understand how we are affecting our planet and ourselves. I believe we can and need to do it again. Above our planet's poles, an invisible force is at work. Hypothesized decades before we were able to measure it directly, this global energy force is responsible for sculpting our atmosphere and driving charged particles into space. It's also why some planets end up uninhabitable altogether. It's called the polar field, and it's a force as fundamental to our Earth as gravity and magnetic fields. For the sake of life on Earth, it's a good thing it isn't too strong. Recent breakthroughs from NASA's mission have finally allowed scientists to solve a 60-year-old mystery by measuring the ambipolar field for the first time, proving once and for all that our planet has a third global energy field. I'm Alex McColgan, and you're watching Astro. Join me today as we unravel the mystery of our planet's ambipolar electric field, a phenomenon that not only powers the Earth, but also has an enormous impact on our planet's field. Depicted in this video as onion-like layers of lines, helps to shield our atmosphere from dangerous solar energy and damaging cosmic rays. And the gravitational field, here as the light flow around our planet, not only keeps us grounded on Earth's surface and stops our
What the
atmosphere
fuck?
from drifting away, but also provides valuable information in the study of Earth's changing climate, sea level rise, ocean circulation, and as you can see, our magnetic and gravity fields are critical features that help make our planet habitable. And with the recent publication of a 2024 paper in the journal Nature, direct evidence has been found for a third energy field, the ambipolar field. To understand this energy field, we need to talk about plasma. Like a solid, liquid, or gas, plasma is another state of matter, which happens to make up 99% of all visible matter in the universe. Plasma is made of ionized particles and is responsible for several well-known phenomena on Earth, like the aurora borealis and lightning. Plasma can form when atmospheric gas density becomes low enough to support the conditions for it, and around 90 kilometers above Earth's surface. This plasma is made up of very lightweight, far...
What?
fast-moving particles, which get trapped along the Earth's magnetic field lines as they move away from the surface. Around the majority of our planet, plasma encounters a barrier that limits its escape into space, known as the plasma pores. Here, plasma co-rotates along with Earth, along its closed magnetic field lines. Until the mid-1960s, the prevailing model of our planet's magnetic field theorized that all of the magnetic field lines were closed and the plasma remained trapped. So, what changed? We went to space. In the 1960s, the first spacecraft flying over our planet's north and south poles could actually detect a supersonic wind of charged particles, or plasma, flowing out to space, including positively charged hydrogen and oxygen ions. This observation led scientists to start wondering whether the Earth's magnetic field model should have an open rather than a closed tail. At the time, scientists already knew that our atmosphere lost some particles to space due to thermal escape. This is a type of atmospheric escape that typically happens when energy from sunlight heats up particles in our atmosphere, allowing them to reach escape velocity and break free of our planet's gravitational pull, kind of like when a pot of water boils and steam evaporates. So it was no surprise that some particles would be escaping into space, but something didn't quite add up. If energy from the sun were the only cause of atmospheric escape, one would expect the particles that were escaping into space to be heated. However, many in the stream were actually cold, with no signs of being heated, and yet they were traveling at supersonic speeds. Scientists hypothesized that there must be another invisible force driving this phenomenon, and in 1968, the term polar wind was coined to describe it, leading to more research and theories into its cause and effects. The idea of a planet-wide electric field was developed to explain the polar wind. But when this was theorized in the 1960s, it was thought that the force was too weak to detect. And at the time, scientists were correct. The electric potential was so weak, it would require very sensitive instruments to measure, and that technology wouldn't be invented for several more decades. Enthusiasm to measure our planet's ambipolar field was spurred again in 2016, after a clue came from the European Space Agency's Venus Express mission. One of the reasons that Earth is possible for life is because of its water. Venus today is dry and barren. However, billions of years ago, evidence suggests that Venus might have had abundant water like our own world does now. This raises the intriguing question: if Venus once had water, where did it all go? Lisa's Venus Express mission offered a potential explanation when it detected a 10-volt electric potential around Venus, at least 5 times larger than expected. This marks the first successful measurement of an electric field on any planet, including Earth. The electric field surrounding Venus positively charged ions like oxygen into the atmosphere, draining it of the essential ingredients of water, and making Venus particles from space. At the time, this could have played a role in draining the planet of its once abundant water. This prompted a question much closer to home. Does Earth have a similar electric field? And if so, why has our planet its water? The electric potential measured around Venus was around 10 volts. In comparison, a standard car battery is 12 volts. But scientists expect our planet's electric potential to be as little as 0.3 volts, similar to a button battery you might find in a watch, and some 20 times weaker than the potential on Venus. It's this difference that may be a key reason why our Earth has been able to keep its water. And that's what inspired NASA's Endurance team to develop a new type of scientific instrument.
Fucking hell, you cunt.
Earth's weak electric field. As a way to reveal our planet's electric potential. Dog Chow's mission, a life-saving PTSD service dog for every veteran in need.
The cloud is limitless, but without limits, your business is exposed. Tenable sees cloud risks others miss, so you can close cyber exposure fast. Tenable, your cloud exposure ends here. L-Pads are gentle and powerful. L-Period Care.
For type 2 diabetes, one weekly Mounjaro could help. Earlier, I explained thermal escape, and I mentioned that particles are able to escape from our atmosphere when they reach escape velocity. That escape velocity is a very specific, predictable speed, but this speed should be ever so slightly slow to Earth's electric potential. And so, by measuring that slowing effect at apogee, or the furthest point in Endurance's orbit from Earth, the instrument would be able to measure the strength of the electric potential around our planet. Such a sensitive instrument would need to be launched at precisely the right location and time in order to ensure a chance at making the observation successful. The Svalbard rocket range was selected for the job. It's the northernmost range in the world, located in Svalbard, Norway, a group of islands in the Arctic Ocean. Here, the NASA Endurance team would be able to launch the instrument on a suborbital rocket through Earth's magnetic North Pole. And on the 11th of May 2022, the team of international scientists did just that. Named after the ship that carried Ernest Shackleton's crew in their 1914 attempt to reach the South Pole and cross Antarctica, the Endurance mission launched its suborbital rocket to an altitude of 768 kilometers, collecting data over 518 of those kilometers before splashing down 19 minutes later in the Greenland Sea. During its flight, the instrument measured a change of 0.55 volts in electric potential between 250 kilometers and 768 kilometers. Space scientist Glenn Collinson, principal investigator from NASA's Endurance mission, said even though half a volt is almost nothing, again almost about the strength of a watch battery, it's just the right amount to explain Earth's polar wind. This first ever direct measurement of Earth's electric field marked a pivotal moment in our understanding of this fundamental planet-wide energy force. The ambipolar field exists in what's called the ionosphere, a region that stretches across 3 out of 5 of our atmospheric layers. Our atmosphere is divided into 5 main layers. The troposphere, also known as the lower atmosphere, only reaches about 20 kilometers above Earth's surface, and is where the majority of weather occurs. Next is the stratosphere, which extends up to about 50 kilometers and contains most of our planet's ozone that protects us from ultraviolet radiation from the sun. This layer has very little circulation and is where commercial airlines usually fly. Above the stratosphere is the mesosphere, extending up to about 85 kilometers. This is where meteors burn up near the bottom of the mesosphere layer are thick enough to slow them down. It's within the upper reaches of the mesosphere that the ionosphere begins, but its influence stretches far beyond that. Starting around 80 kilometers above the surface in the mesosphere, the ionosphere continues outward through the entire thermosphere layer from about 85 to 600 kilometers. This is where auroras happen, and high-energy ultraviolet and X-ray radiation are absorbed, creating charged particles. And finally, the ionosphere ends in the lower exosphere, which begins around 600 kilometers and continues out to about 10,000 kilometers from Earth's surface, where it fades into outer space. The exosphere is where many satellites orbit around our planet. As you can see, the ionosphere starts around 80 kilometers above sea level and stretches hundreds of kilometers into space, where it overlaps with Earth's magnetosphere, a region of space surrounding Earth. Within this massive region of the ionosphere is where we find the ambipolar field, which is theorized to begin at around 250 kilometers. While most of our atmosphere is composed of nitrogen, the upper region of our ionosphere is home to lighter elements like oxygen, hydrogen and helium. When photons from the sun collide with these elements in the upper atmosphere, they can knock electrons loose from the elements in a process called ionization, leaving positively charged particles called ions and negatively charged electrons. Because of the opposite charges of the negative electrons and positive ions, they are attracted to each other and become tethered together by an electric field. It's this electric field that constitutes a major part of the ambipolar field. The electrons within the electric field are so light that the slightest push could send them flying out to space, while the ions are more than 1,800 times heavier than the electrons and sink toward the ground due to gravity. The subatomic tug-of-war works in both directions, but the upward tug from the energized electrons is able to just slightly overwhelm the force of gravity on the ions. This outward pressure of ionospheric electrons is what creates the ambipolar field, depicted here as the sparkling blue glow around our planet. The upward lift inflates our planet's ionosphere and accelerates some ions enough to escape from the atmosphere, creating the polar wind along our cold magnetic field lines. What's more, the ambipolar fields can achieve this acceleration of plasmas without heating them, providing an explanation for the cold plasma scientists have detected escaping from the ionosphere. It's the bidirectional nature of the interaction between ions and electrons that gives the ambipolar field its name. The Latin prefix ambi means both, and polar refers to the polar regions, where the electric field's effects are felt the strongest. Collinson, the Endurance mission's primary investigator, called the ambipolar field an agent of chaos, stripping particles from our atmosphere away into space. Hydrogen ions make up the majority of the polar wind. They are so light, the ambipolar field's upward force of these electron ions is 10.6 times stronger than the force of gravity, leading the ions to accelerate up at supersonic speeds and escape from our atmosphere above the Earth's magnetic poles. Scientists have found that our planet loses about 3 kilograms of hydrogen gas every second, or 95,000 pounds per year. Additionally, the Earth also loses about 50 grams of helium per second, or 1,600 tons of helium gas per year. A smaller, negligible amount, and a much smaller amount of other gases like oxygen. However, not all of this is due to polar winds. It occurs through a combination of factors, including thermal escape and non-thermal escape mechanisms such as polar wind. But don't worry. Despite our planet losing several thousand tons of its atmosphere to space every day, we are nowhere near running out of air. The planet won't run out of oxygen for 8 billion years.
Why the fuck do I feel like somebody that is like a pro or somebody that plays Minesweeper and is a pro at it could legitimately get this almost every time? God fucking damn it, I did not mean to fucking... The middle two are one of my most picked. Middle two, and then, like, these. Have I ever picked these two? Nah. Your ass, bro. Fuck you.
Around 4 billion years from now, our planet may look very similar to how Venus looks now.
No!
Our water will have evaporated, and the greenhouse effect will have become strong enough to melt rock. leaving our planet a dry, lifeless world. Keep
To
in
melt
mind
rock?
that modern humans have only existed on this planet for around 300,000 years. Our species would need to exist more than 3,300 times that length to be around in 1 billion years.
If your grandpa wears one of these, or if your wife wears this, you can count on USAA, membership for the spouses, kids, and then grandkids of those who serve. Count on us. Count on USAA.
Nuevos Häagen-Dazs Belgian waffle cones. That's Das.
Who can solve this equation? Me. Anyone else? Fine. Jake from State Farm. Okay.
It's the personal price plan theorem. If you bundle your home and auto, that can equal an affordable price just for you. Bundle. Just another way to save with the personal price plan. Like a good neighbor, State Farm is there.
Known for creating memories. No one wants to be known for cancer, but a treatment can be. Keytruda is...
While not really important on human timescales, it is still interesting to think about though. And while hydrogen ions may be the lightest and most common type of ion to escape in a polar wind, heavier particles also get a boost from the ambipolar electric field, helping to shape our atmosphere's structure and dynamics. How exactly? Well, now that we've measured the ambipolar field, scientists can delve into all the ways the ambipolar field shapes our atmosphere. Take oxygen ions, for example. These heavy ions weigh half as much when they're immersed in the 0.55 volt ambipolar field. This effect increases the ionosphere's scale height by 271%, which means our atmosphere can remain denser at greater heights than it would otherwise be able to. Endurance's discovery and measurement of the ambipolar field also provided an important key to understanding why Earth has been able to hold on to much of its water up until this point, while our neighboring planet Venus was not able to do the same. It's theorized that any planet with an atmosphere may also have an electric field, and you may recall that earlier I said Venus's electric potential was measured to be around 10 volts, roughly 18 times stronger than the ambipolar field on our own planet. While Earth does lose a constant flow of particles to space, both through the polar wind as well as other types of atmospheric escape, this effect would have likely been much more pronounced on Venus because of its stronger electric potential, leading to the loss of heavier particles like the ones that make up water. The fact that our ambipolar field is so weak may be an important part of why our planet has been able to hold on to its water. We've only just started to explore the depths of how the ambipolar field has influenced our planet and life on Earth, and the endurance scientists have said there are already...
I thought this video was meant to be for the fucking ocean, not space. What the fuck?
Additional measurements of our planet's ambipolar field in the future. Like its predecessor, the new rocket will also carry the legacy of a long-past Arctic explorer, named after the Resolute, a ship that to explore the Arctic in 1850. And now that we've finally been able to confirm and measure the ambipolar field strength, and with a follow-up mission already planned to take more measurements, scientists can start asking some of the bigger and more exciting questions, like what it means for Earth's complex atmospheric dynamics, and how it helps to govern planetary evolution. And doesn't the potential insights we stand to gain from this research feel electric?
Good.
I'll be right back, guys.
Mars Reconnaissance Orbiter has been imaging the surface of Mars for over 10 years now, with its powerful high-rise camera. 10 years of taking photos every day means that its catalogue is huge, and we can pick out pretty much any part of Mars that we want to have a closer look at. Today, I thought it would be really interesting to investigate the sand dunes on Mars and see how they compare to the wonderful sand dunes we have on Earth. You may have already seen imagery of the Sahara Desert, with dunes hundreds of meters tall, or the Namib Desert with rolling sand dunes as far as the eye can see. Did you know, though, that there are 5 different types of sand dunes, and that Mars has a type of dune Earth doesn't have? And also, what are the biggest dunes on Mars? The most common type of sand dune on Earth is the crescent, or the Barkhan sand dune. While not always as distinctive as these dunes in this image, they are plentiful and found in most sand deserts. They are defined by this kind of crescent shape with arms, and they are usually wider than they are long, like you can see here. They form like this because in these places there is only one dominant wind direction. They have a shallow slope on one side that faces the wind, and a slip face on the other side. They are a type of transverse dune, as they move gradually over time as the wind blows, whipping sand from the front, over the top, and down the slip face. When many of them merge, they can create an almost wave of sand, smooth on the side facing the wind, with a slip face away from the wind, moving gradually over time with the wind's direction. They are also in plentiful supply on Mars. All of the ones I'm about to show you can be found at the base of various large craters. Going to this old crater near Mars's equator, Barkhan dunes can be seen lumped together somewhat here in this plane. This happens when there is a plentiful amount of sand and the dunes merge together into a big, lumpy, transverse dune. But individual dunes are really evident a bit higher up, where the sand is contrasted against the bedrock. Here are some more, found in Arkhangelski crater. When there is a smaller amount of sand, the dunes tend to stay separate, which looks really peculiar from above. These dunes do move, although very slowly. Here's a couple of examples of dunes on Mars, moving slowly over the course of 2 to 3 years. Scientists originally thought that sand dunes would stay pretty motionless on Mars, as sand dunes require wind to move them, and Mars only has about 1% of the atmospheric pressure at the surface compared to Earth, whose winds can easily move sand. We knew the wind on Mars could pick up tiny dust particles, but it would require extremely strong winds to move sand. This could be helped though by the fact that sand on Mars is not exactly the same as Earth sand. In my Opportunity video, I mentioned that the sand particles Opportunity analyzed were far smaller than what we're used to on Earth, which may aid the movement of these dunes. But what happens if the wind is bidirectional? Going back to Earth, a beautiful type of dune which can easily be seen all the way from the International Space Station is the longitudinal, or Sif dune. Sif is the Arabic word for sword, which describes these dunes nicely as they are long and narrow. These linear dunes can be hundreds of kilometers long and are often found in parallel sets, separated by gravel or rocky corridors. These occur where wind directions can flip over, meaning that these ridges have a slip face on either side of the dune, making them appear quite sharp. Sif dunes also appear on Mars, and in my opinion, the most beautiful example of it can be found here. Again, found at the bottom of a crater, these dunes look remarkably similar to each other, including this dusty band found on each one. Although we're
that ain't
totally
funny, bro.
sure how
That ain't funny. That ain't fucking funny.
Is that they are the result of wind
No one
changing around Barkhan
in
dunes.
today's fucking
In this image,
history
some Barkan dunes seem to be mid-process
likes that.
to forming into
Unless
seep
you
dunes.
like doing crack, then go fuck
It's a
yourself.
really pretty image that seemingly tells a story. To our right here, we have a mesa being eroded, feeding sand into the valley below. Then you have these beautiful examples of Barkan dunes, which show the step-by-step process of becoming seep dunes. Another spectacular example of this, a bit further into the process, can be found here. The
So are
contrast of the
you.
different materials in the image are stunning. And the dark sections are the sand dunes merging together. The third type of dune is the dome dune. Typically, these are not very big on Earth, usually only a few feet high. They have no slip face, they are smooth all over, hence the name. They are quite rare, and usually found in and around other types of dunes.
Blah blah.
And yes, these are also found on Mars. Here's a field full of domes, a few of which can be seen starting to cross over into Barkan dunes. And in this impressive expanse
Motherfucker.
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 These dunes continue on way beyond this image. You have wobbly lines of dunes with domes on the end of them. These domes seem to be much bigger here than they are on Earth. The domes here tens of meters across. This field is indicative of a change in wind direction, as the lines are nowhere near as straight as in some of these previous images. The fourth type of dune is a parabolic dune, which is the opposite of a Barkan dune, meaning the slip face is on the other side compared to a Barkan dune. These occur near coastal regions,
I'm a
and
YouTuber.
form the way they do because something, often vegetation, anchors the arms of the dune in place. Lack of vegetation on Mars means it's a bit tricky to find parabolic dunes. The closest thing I found is this beautiful image. A dune wrapped around a large mound in the middle. The dune is clearly moving from left to right in this image, and you can even see the shadow of the slip face just by here on this side. The existence of this dune is heavily influenced by the size and shape of this mound, funneling wind along its walls. The fifth and
I got
last
shit
type
to
of dune
do.
is the biggest type, the star dune. This is a dune where wind direction changes frequently, meaning the dunes in this region have 3 or more arms, and are often stationary, just building up over time. This impressive image is the Sahara Desert as seen from the ISS, and it is full of star dunes. The scale of these dunes truly is impressive. Zooming in, you'll realize that these dots are people. And of course we have star dunes on Mars. Some are small, a collection of dunes merged together, but others are massive, like these found in Russell Crater, which reach far beyond
Motherfucker,
this
I
image.
have an intro
As
that
this
I
image is found
put
near
work
the
into.
poles,
Yeah.
Carbon dioxide ice can form on these dunes.
I don't think I started
During
the
Martian
intro, but
spring, the carbon dioxide sublimates, which dislodges loose material, leaving these streaks. Moving to another image, again near Mars's pole, we find one of the most beautiful images of Mars I have ever seen. This image was taken just as the sun was either rising or setting, meaning a lot of the image is shadows cast by dunes. I love this as it provides a sense of depth to the image. These again are big star dunes with their individual arms reaching out for kilometers. There's one last thing I want to talk about with the dunes of Mars. Have you ever been to the beach and seen sand ripples like these? These are actually a type of transverse dune.
forming perpendicular to the direction
0 0 0 0 0 and 0 0 0 0 1 0 0 0 0 0
with a meter or two between the ripples. This size makes it difficult to see from space, but luckily we have another rover on hand, Curiosity, seen here in this image. To take this remarkable photo of them.
Shut your ass up. Shut your bitch ass up.
And it is a fitting reminder that although Mars may appear quite familiar to us, it is still a world full of secrets, unexplored facts, and there is still so much we can learn from it. Thanks for watching. Making this video required some long-term planning and work, which we were only able to do thanks to the consistency and sustainability of your memberships as astronauts on Patreon. A huge thank you to everyone who has signed up, and if you'd like us to make more videos like this, you can join with the link down below. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Meanwhile, click the link to this playlist for more Astron content. I'll see you next time.
How the
If I were to tell you that the cycles of the sun could affect your entire life, you might think that I was suddenly taking a turn away from astronomy and into astrology. While there are many people in the world who believe that you can live...
Man, there ain't nothing going on in chat.
Planets, it's not a position I tend to take on this channel. I'm more interested in the beauty of space and the mechanisms that explain why it is the way it is.
God damn it.
But sometimes there is a grain of truth behind even the most surprising of stories. So allow me to put on my prophesying hat. While I'm no writer of horoscopes, I will predict that based on the current state of the sun, over the next few years, you might be more likely to experience bad health, less reliable technology, see warmer weather with fewer clouds, and possibly could be influenced in other surprising ways. How do I know? Because it turns out the sun, that giant ball of fire in our sky, is not just the place we get our energy from. Science is starting to show that its 11-year cycles might just be the metronome measuring out how life on our planet tick, tick, ticks.
Bruh.
I'm Alex McColgan, and you're watching Astron. Today we're going to look at the sun cycles. In particular, I intend to show you exactly how the cycles of the sun are already influencing the course of your life. It's no surprise that the sun is influential to life on Earth. After all, in many respects,
either he legitimately just fucking gave up,
life on Earth
or he
needs
just
energy to function, and the
is
sun
taking a really
provides
fucking
that
long time
energy.
to take his fucking, to type out his fucking answer, in which case he must actually be on crack.
It's hard to find anything on Earth that could live without our
Because
sun.
really, it shouldn't take you this
But
long.
beyond the gift of that life-sustaining energy, it's easy to
The
think
type.
of the sun as fairly static. We see it rise and fall in the sky, but we rarely notice it undergoing
Today
any sort of change.
it has to be like one of the
This,
most
however, is
boring
an illusion.
fucking
The
days
sun changes all the
I've
time.
played BG.
As science has advanced and we've been able to shield out the worst of the sun's glare, it became possible to study the sun's surface. As early as 1610, it became clear that the sun was a boiling, shifting sea of barely restrained plasma, which frequently wasn't restrained. In spite of the intense gravitational force holding it all together, the nuclear reactions taking place in its core are so hot, reaching 15 million degrees Celsius in its center, that plasma bubbles and bursts on its surface, erupting into solar flares that blaze in all directions. Sunspots, dark patches of the sun's surface that are filled with intense magnetic fields and can be between 1,600 and 160,000 kilometers across, form, drift, and vanish. Coronal mass ejections explode out of the sun's corona, the atmospheric zone above the sun that is strangely 200 times hotter than its surface. It's hard to find a place in the solar system that is as active as the sun. What many people do not realize is that that activity waxes and wanes. The sun operates on an 11-year cycle that alternates between a period of low activity, the solar minimum, to a much higher level, the solar maximum, and then back again. Sunspots, solar flares, and CMEs all become more common during the solar maximum. You are 50 times more likely to see a solar flare during solar maximum compared to the sun's minimum, and large CMEs go from happening once every few days to multiple times in a single day. This is known as the Schwabe cycle. Interestingly, this represents 1/2 of a larger cycle known as the Hale cycle, which maps the changes in the sun's magnetic polarity. Once every Schwabe cycle, every 11 years, the sun's magnetic north pole and south poles swap places. When another Schwabe cycle occurs, the poles swap back. Tick, tick, tick. This constant rising and falling of solar energy levels thrums through our planetary system, rising and falling like a heartbeat. And surprisingly, even though we can't see it, we here on Earth move to its rhythm. We don't really understand why the sun goes through this cycle. It's clearly related to the magnetic processes that exist within the sun itself. Yet, although we have observed these cycles in action for the last 200 years, and have seen evidence of their influence on the Earth over the last 10,000, we're still no closer to figuring out why the sun cycle has a length of that particular time period rather than any other. What force drives it? Lacking any other obvious answer, some scientists have tried to connect the orbital length of Jupiter, also about 11 years, to this cycle length. This could easily be a coincidence. Although Jupiter represents 2.5 times the combined mass of all the other planets in the solar system, and definitely exerts some gravitational pull on the sun, its orbit cannot explain the variations, seemingly
I mean, like,
random
funny
of the sun's
insults as in
cycle as it goes.
ruining your fucking life.
The sun is a mystery to us, but its influence on Earth, that is much easier to see. It begins with the space around us. Space is more and more important to modern civilization, so it shouldn't be surprising that CMEs and solar storms streaming out from the sun more regularly would have an impact on the technology we have up there. Scientists are able to predict the arrival of a solar storm, known as a geomagnetic storm, by the time it arrives at Earth, days or even weeks in advance. This allows astronauts to go into safe shelters to hide themselves from harmful rises in radiation levels, and it also allows the delicate hardware on satellites to be powered down to prevent that hardware from being fried. This is important, as solar radiation can cause unexpected electrical currents to form in wiring, overloading systems that haven't gone into a safe standby mode. But there's another aspect to geomagnetic storms that you might not expect. All of that radiation has an impact on the atmosphere itself. It warms it.
Never mind.
Just a little. As the atmosphere warms, it expands, and this has an impact on our satellites. In space, there is no
What happened?
drag,
Wag.
so objects
Wag.
can orbit
Wag.
practically forever. Well,
Fuck
this
it.
is
Wag.
entirely true, and satellites in low Earth orbit do occasionally, about 4 times a year, need to expend fuel to correct their orbits, as there is still a tiny amount of atmosphere up there. But when a geomagnetic storm occurs, the atmosphere blossoms upwards, and low Earth orbit satellites have to maneuver every 2 to 3 weeks to keep from falling from the sudden friction. And this isn't always enough. In 1989, there was a geomagnetic storm that was so powerful, it knocked the NASA Solar Maximum mission out of the sky, as an increase in atmosphere suddenly slowed the satellite down. Ironically, the mission had been studying solar flares. This is not an isolated incident. NORAD, the Northern American Aerospace Defense Command, has to relocate hundreds of satellites after each geomagnetic storm, as they have been knocked out of their old orbits. Radiation can also influence our ionosphere, filling it with charged plasma. This can have a slight lensing effect on your GPS systems, reducing their accuracy from within a meter to over 10 meters. The next time you look on Google Maps and it thinks you might be a street across from where you are, a geomagnetic storm might be to blame. Our power grids brace themselves every 11 years for the uptick in these current-inducing events to keep themselves from being overloaded. Amateur radio enthusiasts and airline pilots find their high-frequency radio range dropping significantly as radio waves get deflected or even blocked completely by the more powerfully charged ionosphere. As I predicted in my horoscope, this all adds up to some less reliable technology. The fact that the next solar maximum is expected to arrive soon, in 2025, makes me quite confident in my prophesying. There are some bright sides to this.
Damn it. Forgot, I didn't do the one. I didn't do the one that, didn't do the one part. The kill yourself. I didn't do the one with the part with the kill yourself part in it.
Rises in sightings from a few times a year to as many as twice a month during the most energetic parts of the sun's 11-year cycle. So much for the sun's influence on space and our technology. You might think that that's the end of it. The sun cycle might influence machinery, but it's not going to make much difference on anything alive, right? If you think that, you'd be wrong. It's not for nothing that the rest of my horoscope mentioned poorer health. There's growing evidence that the sun cycles can even influence ecosystems and species themselves, including humans. Some of this is incidental. When the Schwabe cycle is at the solar minimum, the sun exerts less pressure through its solar winds, which means, ironically, that we get less protection from our heliosphere from cosmic radiation. This form of radiation is highly energetic, but fortunately rarely makes it through our atmosphere for that very reason, as it's likely to be absorbed or deflected by a passing air molecule. But reaching the atmosphere is all that's needed to produce an effect. There is a theory, although still far from certain, that this extra radiation could be creating nucleation sites in the atmosphere that seed extra clouds, influencing our weather. Even if that's not occurring, during solar maximum, the space weather hitting our atmosphere can raise global temperature slightly. As my horoscope at the beginning predicted, a warming of the weather. Not by much, it should be said, less than half a degree, and the temperature always eventually returns to where it started. But it's enough that it's noticeable to species paying attention to temperature. For instance, to decide when to start the mating season. Studies of birds have shown that on warmer years, they tend to lay eggs earlier. Curiously, a study published in 2009 by researchers in the Netherlands went as far as to show that the laying times of blue tits were also affected by the number of sunspots occurring, which even the researchers found hard to explain. It's not like birds can look at the sun to see how many sunspots there are. Nevertheless, a link seems to exist, according to the 5 nesting groups that were looked at. This isn't something that affects just blue tits, or even species like homing pigeons that are sensitive to magnetic fluctuations, who fly different routes.
I'm bored, but I don't want to do anything. That's just fucking basically torture.
Bad health. There are numerous studies on how solar cycles might influence us. In 2011, a study spanning 2 decades of nearly 1/3 of women in Holland discovered a peak in 6 cervical pathologies that took place just after solar maximum, when the sun's radiation was hitting hardest. The study also checked 1 man during the same period, which admittedly is a much smaller number of candidates. Still, it was interesting to note that the man experienced slight elevations in oral temperature, pulse rate, blood pressure, and respiration rate that took place soon after solar maximum too. It's not just physical. There's even an influence on the rate of mental disorders. A study in 2006 looked at 237,000 clients in the main Medicaid database collected between 1995 and 2004. They found that, of all those clients, Those born during higher energy chaotic cycles experienced an increased rate in mental disorders. If this is the case, then the cycle of the sun at the moment of your birth might just have influenced the course of your life. It's not quite star signs, but astrology might just be onto something, at least with one specific star. Ultimately, the science on this is still ongoing. It should be stressed that any health impacts caused by these cycles are extremely minor. As one researcher put it, it took hundreds of thousands of patients to even notice that there was a health impact. The sun cycle should not prevent you from living your life. We're currently heading towards a solar maximum, predicted to arrive in 2025. But for those who are worried, living through or being born in a solar maximum isn't all bad. The same study suggested that this radiation might lead to a rise in creativity and adaptability. Perhaps it was during one such cycle 80,000 years ago.
The fuck was I doing?
Abstract thought and consciousness. If so, if they gave us the means to perceive the universe, we have much to thank solar maximums for. We wouldn't be us without them. When you think about the North Pole, you don't expect it to go anywhere. And you certainly don't expect it to change places with the South Pole. That would just be wrong. Our magnetic compasses would all point the wrong way. We'd need to update our maps. Birds would probably be horribly confused. And yet, although they sound like something out of science fiction, geomagnetic reversals like this are real. They've happened before, and the process behind it might be a lot more dangerous than you'd think. To be clear, it's not the reversals themselves that are potentially dangerous, it's the buildup. During those times, the Earth's magnetic field, the shield around our planet that keeps us safe from deadly solar radiation, will drop to as low as 10% of its current strength, leading one group of scientists in 2021 to predict climate shifts and mass extinctions, and others to describe satellites being destroyed, electrical grids going offline,
what the beep? What the beep?
For hundreds or even thousands of years. This is troubling when you consider that we are a couple of 100,000 years overdue for our next geomagnetic reversal, and based on fluctuations in the Earth's magnetic field that scientists are detecting right now, the build-up to a geomagnetic reversal may even have begun already. Which begs the question, should we be worried? I'm Alex McColgan, and you're watching Astrum. Join with me today as we explore the science behind geomagnetic reversals and find out whether the next one will be an apocalyptic scenario or whether it'll lead to nothing more than a few lost birds. What truly happens when things go south? Let's start by trying to understand where the Earth's magnetic field comes from in the first place. It's not a given that our planet would have a magnetic field. The two planets flanking us, Mars and Venus, do not have one, and yet the Earth does, which is a good thing, as without one, there is a very real chance life would not have been able to arise here in the first place. Thanks to the protective cocoon of this field, deadly solar radiation is deflected away from the planet's surface, allowing things to flourish without all that radiation breaking down our DNA, causing mutations and cancers. Scientists are still trying to figure out all the particulars of why certain planets have fields and certain others don't, but the current leading theory is that the Earth's core acts as a giant dynamo. It's a principle of physics that you can use electrical fields to create magnetic ones, and vice versa. This is the principle that power plants work under. Moving a magnet through a coil of wires causes electrical current to start to flow, as that changing magnetic field exerts a force on the electrons present there. But similarly, the motion of electrons creates a magnetic field to form in perpendicular circles around the direction of motion, in accordance with Faraday's law of induction. But the way this applies to the Earth's core is a delicate, complicated process. To start with, our core needs to be at least partially liquid, which fortunately is true. Above the solid inner core that lies at the heart of our planet is a liquid outer core, where the pressure isn't quite high enough to keep things in a solid state. It is very hot in the outer core though, 6,000 degrees Celsius at its warmest point. So hot that it rivals the surface temperature of the sun, which, when combined with the lower pressure compared to the inner core, is more than enough to keep the iron and nickel that makes it up flowing down there. The temperature drops as you move away from the center of the Earth. This gets circulation going. Hot, conductive material from the warmer, deeper regions of the outer core rises, then cools, then falls again, creating loops and currents of flowing material. Our electrical field starts to be generated. But if there are many of these flowing loops, which in theory there would be, why does Earth only have one North Pole?
You shouldn't need money to play a game.
Surely the created magnetic fields would be all over the place. Well, there is thought to be an extra force at play that takes all these fields and unifies them, pointing them in the same direction. This force is thought to be the Coriolis effect. Dynamo theory states that the Coriolis effect causes these flows of iron to not rise and fall as straight lines, but as spirals. The spinning of the Earth causes them to gently be spun in turn, creating giant springs. As each segment of each spring is creating a magnetic field in a circle around it,
Cows!
the net result
Blue
is that
cows!
creates a solid, unified field
Cows!
that moves in the same direction upwards, while the outside brings that magnetic field looping back down again and back into the bottom of the coil. In short, it creates the well-known magnetic dipole north and south that we see today.
Bounty is 2 times more absorbent, so you can get more done with 1. The quicker
The fucker Pebble.
Getting too cool? Give them Temptations Creamy Puree.
Oh my god, bro.
Right now, at
Just
US
no,
Cellular, you can get
no,
4 free
get
phones
some.
plus 4 lines for $90.
Hey, we're tired of having the wool pulled over our eyes with these hidden requirements. What aren't we seeing?
Yeah. Do we get our choice of free phones?
Yep, you get the latest phones.
I bet we have to trade in our old phones, though.
No, sure don't.
Wow.
I bet. Almost. Higher. Yes. Nope.
Get 4 phones plus 4 lines for $90 with no trade-in, and we'll pay off your current contract when we switch. US Cellular, built for us.
However, if there's anything that you should take away from this, it's that this process is precarious, as it is based on a lot of liquid iron essentially just sloshing around, which is not very consistent. Our magnetic field thus has little fluctuations and wobbles all the time. We see this in different ways, but a big one is that our North Pole is constantly moving. Since scientists began keeping track of it in 1831, the North Pole has gradually shifted about 1,100 kilometers, leaving its original location in Canada and moving up towards
Don't tell
Siberia.
me it's
Its rate motion is also
Yo, my server's dead!
16 kilometers a year to roughly 55 kilometers a year.
My chat's bugged.
This might still be akin to just the momentary wobbles of a spinning top though. Yes, it deviates somewhat, but it always remains roughly upright. That's a far cry from a complete reversal. However, scientists are certain that such reversals have happened before. They even have a specific number, 183 times in the last 83 million years. How do they know? The answer is
And yet I've been playing Block Bingo since 2017. That's when it was created. And I've been
it can contain small amounts of iron. As these can move
without money, and I've been thriving.
Themselves in the direction of the Earth's magnetic field. However, scientists noticed that there were layers of geological history where the iron was pointing one way,
bitch, what
and
the
layers
fuck?
where it was pointing in the reverse direction. Their explanation: the entire pole of the planet had flipped. On average, these flips seem to happen every 450,000 years, although the last few have only got 300,000 year gaps between them. Comparatively, it's been 750,000 years since the last reversal. You might think that we're overdue for one, and some have made that claim. However, scientists have found that there's little rhyme or reason to the timing of these flips. One of the longest gaps between flips took place in the Cretaceous period, and it lasted 40 million years. The record holder, the Kierman reverse superchron, was 312 to 262 million years ago. 50 million years with no reversal. Scientists are still trying to understand what causes these flips. However, the current theory is that something, perhaps some interplay between the mantle and the outer core, causes a fluctuation in the core spinning. This disrupts the spiraling shapes of the core's flow, breaking them down. The magnetic field of the Earth stops being unified and generally becomes a sprawling mess, fighting against itself. Several poles might temporarily arise during this period of shifting magnetic confusion. While in time things settle down and the spirals reassert themselves, it seems random as to which way they will do this, meaning about half the time our magnetic North Pole reappears over the geographical South. This reasserting can take 1,000 to 10,000 years. Alright, but would that really be the end of the world? Why does this matter? Well, during that period before the poles reassert themselves, our Earth's magnetic field drops to as low as 10% of its current strength. In theory, this could leave us much more vulnerable to all the solar radiation space throws at us. We could see auroras reaching much further south during that time. Skin cancer rates would increase. Our satellites would find themselves with not enough shielding. Radiation would fry their circuits, causing them to malfunction, shut down, and potentially even fall from orbit. Our electrical grid would be much more vulnerable to solar storms, which could lead to large segments of the Earth's population without power. With no electricity or satellite communication, it would be a devastating blow to our global civilization. It could be worse than that. A research team from the University of New South Wales in Sydney even linked one of the most
how the fuck do you forget your...
the Lachamps event, a temporary 800-year wobble rather than a full blip, to megafaunal mass extinctions in Australia, including the deaths of Diprotodon, giant Australian wombats, and Procoptodon golaya, giant kangaroos. Temporary wobbles like this are known as geomagnetic excursions rather than full reversals, and they happen over much shorter time frames. Their transition periods can last as little as 200 years rather than 10,000, which can be much more difficult for species to adapt to. In their 2021 study, they argued that there was a spike in atmospheric radiocarbon caused by the
Do I need to call 911?
Indicating climate shifts that could have led to these extinctions. The timing lines up uncomfortably. But how real are these risks? Honestly, it's a mixed bag. A point in our favor is that other than this recent study, there is no indication that magnetic field reversals have ever coincided with mass extinction events. It seems like many reversals have come and gone without affecting animal or plant life at all. And even in this study, such mass extinctions
Motherfucker, what? That's why I don't do that shit. Plus I don't even have a bank account, so if I wanted to, even if I wanted to, no. So even if I wanted to, I'd be fucked. I wouldn't be able to.
Changes would take many lifetimes to complete, even at their fastest. This would be slow enough that we could come to terms with our new reality. If our satellites don't have enough shielding, we would have time to build some that would better protect it. If solar radiation becomes a larger risk, we could remain indoors more. sun cream might become more powerful to mitigate the dangers of cancers, if not remove them entirely. And according to NASA, even if our field were to significantly weaken, it's not like we would be left without protection. Our atmosphere itself can catch radiation, meaning that we would remain safe from solar winds and cosmic radiation, at least to some degree. It would take far longer than 10,000 years for our atmosphere's ozone to be stripped away. But I would be surprised if there wasn't at least some turmoil, at least while we adjusted to living under a reduced magnetic field. Big changes to how a society operates are always painful. And this isn't entirely hypothetical. Did you know the Earth's magnetic field has been steadily weakening for the last 200 years? It would take another 1,300 years for it to vanish completely, so there's plenty of time for it to stop its current downward trend, and there's no reason to think this isn't just a temporary wobble. But on top of that, there is also the South Atlantic anomaly to consider, a section of the Earth's magnetic field that is already showing signs of significant weakening that covers most of the space around South America and the neighboring ocean. This zone might not influence life on the ground, but is dangerous enough that it has fried satellites and threatened astronauts. The Hubble telescope has to turn itself off every time it flies through it. Imagine that, but across the entire globe. That's what we might expect while the poles are reversing. Concerningly, the South Atlantic anomaly has been growing continuously since we started keeping track of it, possibly suggesting the approach of either another geomagnetic wobble like the Shams event, or that a full-blown reversal is already upon us. If it happens, it won't likely be something that ends civilization as we know it. But if the study about Australian megafauna is correct, it isn't going to be without impact either. Species could die.
Oh shit.
Humans will have to accommodate a very different, more hazardous space environment. It's interesting to learn about geomagnetic reversals and their potential impacts on the planet. But while we are not likely to see what happened in our lifetimes, for the generations of humanity after us, this might turn out to be a lot less hypothetical. They might be seeing it firsthand. The Moon. Earth's natural satellite, orbiting approximately 384,000 kilometers away. A celestial object.
A random fucking frustrated noises.
Using its regular motions
because I don't fucking know why.
Its dependable rhythms helped ancient civilizations to track when to plant crops.
What?
And its waxing and waning phases cemented the moon's place deep in the heart of symbol and tradition. It's a wonder, a necessity.
So, did you find everything there was to learn about?
While the moon's desolate beauty has captured the vision of poets,
what the fuck were you listening to this one? Turkmenistan? Turkestan? I don't know, one of the stands.
A 19-year cycle that brings unexpected
learned everything you needed to learn?
Huh?
I don't know, you're watching something about
that in the middle of the 2030s,
Turkmenistan. I don't know, one of those
things
one of those countries that used to be part of Russia but broke off from Russia, and so now they're just on their own. They don't know what the fuck to do because everything's fucking falling apart on them.
I
don't know, you were listening to it this morning. I'm like,
join with me today as we learn about
I'm going to bed. I love you. Good night. Sweet dreams. See you tomorrow.
Night.
9 o'clock. I gotta go to work tomorrow. Even though I don't want to go to work tomorrow because they're probably gonna fucking write me up. So that's good.
Why?
Love you. Bye.
Why?
Because I had a little bit of an attitude last week, and somebody narked on me. Evidently, they don't know snitches get stitches. As soon as I find out who the snitch was, bitch gonna get stitches.
You mean you're gonna push him off a bridge?
Yeah, whatever. I don't care. Whatever.
Oh shit.
I've never been in trouble with HR before, so they're gonna fire me over my first offense. And all right, I'll take unemployment and I'll go help and take care of Grandma.
I wanted some ice. That's why I got.
Are you done with that cup?
Yeah.
Okay.
Yeah. Okay.
If you're drinking water or drinking some ice, that's fine. I don't care. Love you.
Love you too. Ow. Ow. That hurt. Where the fuck? Oh. I'm fucking bored, bro. Yep.
Much like the sun, The moon is an inescapable part of life on Earth. The moon has an immense impact on our planet. You likely have already heard how its cycles influence our wildlife, affect our climate, and create tides. We tend to imagine that the moon and the Earth's gravities cause them to circle each other in a relatively stable, synchronized harmony. But, as is so often the case, nature is not as simple as we imagine it. Instead, every 18.6 years, the moon's orbit undergoes a subtle revolution, a shift in its alignment between us and our sun that causes high tides to grow even higher, tipping us over the edge into dangerous flood territory. But let's delve into what this subtle revolution is. Its name is the lunar nodal cycle, or the precession of lunar nodes. This complex name refers to a specific feature of the moon's orbit of the Earth. You likely know that every 29.5 days, the moon orbits the Earth. However, this orbit is not flat, or, to be more specific, there is a 5-degree difference between the angle of the moon's orbit and the ecliptic plane, the 2D plane on which the Earth orbits around the sun. For half of the month, the moon is slightly higher than the plane of the ecliptic. For the other half, it drops below it. Naturally, this means that there are two crossover points, or two nodes, an ascending node and a descending node, that mark the point where the moon goes from one side over to the other. And it is these nodes that move over the course of the 18.6-year cycle, slowly rotating around the planet in one complete revolution. The nodes themselves are what causes the problem. To understand why, let's recap what we know about tides.
God damn it, I fucking drew myself. God, no.
With how the moon's gravity pulls the Earth's water towards it, causing a bulge in sea levels on the side closest to it that we call high tide. You likely also know that this happens on the side of the planet furthest away from the moon. Rather than being caused by gravity, this second bulge is caused by centrifugal forces, as the Earth and the moon's gravitational pull on each other causes them to behave like two dancers holding each other by the arms and spinning across the dance floor. While it's mostly the moon moving, due to the Earth being much more massive, the Earth is also swung around a little. The water behind it is thus trying to fling off into space through its raucous spinning, causing the second high tide. The sun also has a role to play in tide formation, albeit to a lesser degree. It's a bigger mass, which would cause a greater pull if it were closer, but its further distance means that the sun's effect is only 1/3 as big as the moon. When the moon and the sun are aligned, we get extra large tides called spring tides. This happens 6 to 8 times a year. When not aligned, they partially cancel each other out, causing smaller tidal extremes known as neap tides. So now consider the influence of lunar nodes on this tidal tug of war.
Let's see, where's the
During spring tides, the pull of the sun and the moon working in unison causes the highest tides and the largest risk of floods.
I'll be right back, guys. I have to
The
go.
sun and the moon are never more aligned than they are at the node. During the rest of each 9.3-year phase, they are not quite tugging in the same direction, so tides are more temperate. At the node, that's where things get more serious, and risk of floods become highest. The last time this alignment occurred in September 2015, the UK and the US both issued major flood warnings to its citizens. In September itself, there were floods, albeit minor ones, but it was only when heavy rain combined with the strength of the lunar nodes a couple of months later that the real damage was inflicted. In the US, in October, South Carolina saw flash flooding that caused property damage and people having to be rescued by emergency services. At the end of December 2015, the UK was hit by some of the worst floods it had seen in a century. Combined with the power of Storm Desmond, flooding and storm damage caused an estimated £1.3 billion in damages. These floods can be highly damaging. But that in and of itself doesn't completely explain NASA's worry for the upcoming alignment in mid-2030. There is an extra element at play beyond the regular rhythm of this rising flood risk we have been seeing through the course of human history. Unfortunately, the next node's alignment with the Sun promises to be particularly devastating. The danger is that this phenomenon is combined with an already strained system, even more strained than it was in 2015. Climate change has resulted in steadily rising sea levels. When the next node aligns with the Sun in the mid-2030s, this will likely lead to a dramatic increase of floods on planet Earth. Worryingly, a new study led by NASA's Sea Level Change Science team predicts that almost all US mainland coastlines, Hawaii, and Guam will have a huge leap in flood numbers when this happens. Some predictions claim this node alignment could cause 4 times the amount of flooding from one decade to the next, which will damage infrastructure and change our coastlines around the world. This means human life will inevitably be affected by these floods, impacting shelter, clean water supplies, electricity, as well as the increased risk of waterborne disease outbreaks like hepatitis A and cholera. Plus, the receding floodwater can create stagnant pools of water where mosquitoes gather, which can spread other diseases like malaria. This has a knock-on effect on economic issues, as these natural events can make coastal life unaffordable, with increased cost of insurance on these homes, or an inability to find insurance at all, which could cause a reduction in asset value in the community. Consequently, this lunar nodal cycle will damage the quality of life in coastal communities, where infrastructure may not be rebuilt or adapted to this force of nature. It's not just bad for humans. Ilya Roshlin, a visiting professor at Rutgers University, analyzed that the peak of the lunar wobble, where high tides are higher, can drown salt marshes. Salt marshes are a habitat for a range of species, such as invertebrates, and these floods can cause these creatures to drown, which means that other species like fish, seabirds, and others who rely on invertebrates to survive also suffer. And they aren't the only ones that rely on salt marshes, as salt marshes hold a multitude of marine life, which includes 75% of all fishery species. This means that the lunar wobble impacts the food chains of humans and animals, causing disturbances to their natural habitat and impacting their populations. While this all does seem fairly doom and gloom, it's interesting to note that not all ecosystems on the planet are negatively affected by flooding and high tides. Ecologist Neil Saint-Alain of Macquarie University analyzed that the lunar nodal cycle impacts heavily on the expansion and contraction of mangrove canopy cover over most of the Australian continent. The analysis showed that the peaks of the lunar nodal cycle coincided with the cover of the mangrove canopy. It showed that when the lunar wobble is at its minimum phase, it causes the mangrove ecosystems to become very dry, which leads to thinner canopy cover. Yet, when lunar wobble is at its maximum phase, mangrove cover increases. Mangrove canopies are beneficial to Earth's environment, as they are complex ecosystems that fight against climate change, protect wildlife, and shield coastlines. They can also absorb 4 times as much carbon dioxide than rainforests of the same size. Their growth is vital to the welfare of our planet, so it's not all downside. Still, it's clear that if we don't plan ahead, coastal cities and environments will face a serious crisis. The all-important question, then, is what can we do about it?
The cloud is limitless, but without limits, your business is exposed. Tenable sees cloud risks others miss, so you can close cyber exposures fast. Tenable, your cloud exposure ends here.
My friends and family are counting on me. I will save them!
Fuck you.
How impressive you are! Deja 2, now in English. Experience it on IMAX in 3D August 22nd.
Check out these deals of the week at Walgreens. Shop weekly deals at your store or at walgreens.com.
It's time to start seeing your to-do list for what it really is, your get-to-do list. The Polaris Ranger 500 is the right vehicle at the right price to help you make the most of your property, making work part of the reward.
One method is better protection. As mentioned previously, the protection and restoration of mangroves can act as a shield against flooding, as they can mitigate the vulnerability of communities on the coastlines. More specifically, mangroves can avert damage by decreasing the height and energy of waves as they pass through mangrove forests. The above-ground roots and branches diminish the height of the waves, and thus the waves lose energy, ultimately stopping the waves emerging onto the seabed and engulfing the sediments. The mangrove's roots and branches also reduce wind energy, which can stop the formation of waves. According to reports, densely packed mangroves can halve the height of a wave through just a 100-meter passage. For comparison, in an open forest where roots and branches are more sparse, it would take 500 meters for a wave to halve its height. So, preservation and reforestation of these mangroves, or plants with a similar capability, can become a great shield against upcoming floods. Another possible solution is to learn how to live with these flood-heavy conditions, working with nature rather than against it. For example, let's take a look at the flood defenses in the Netherlands, where 1/3 of the country is below sea level, and another third is at risk of flooding. They've built infrastructure that works with water and manages the rising sea levels. They do this by designing facilities like polders. Polders are bits of land below sea level that have been reasserted from a body of water. It's always fully or partially surrounded by an embankment to keep the water out that comes from either the sea or a river. These polders offer a network of drainage canals and pumps to manage water levels by disposing of excess water and running water back to the sea or river to make sure that the water doesn't run over land. Polders can be used to protect houses, farms and factories, and thus are used a lot around the country. The Netherlands also built dams and utilized sand dunes to create ways to stay dry in their swampy land. This shows that there are ways in which we can observe nature and live alongside it. So, the bad news is, behind its ethereal beauty, our moon hides a power that, if just so combined, is set to overwhelm humanity's coastal settlements. However, there's always a bit of good news too, as knowledge is a power of its own. By understanding our plight, we can look for solutions, both among already existing ideas and ways forward that have yet to be discovered. If we are to endure what is coming, it's high time for us to use our innate creativity and drive to adapt and survive, to work with our planet rather than against it. In the middle of the day, the sky starts to darken. It's as if dusk has fallen early. People look and notice something is happening to the sun. A dark shadow moves before it, gradually devouring every last trace of brightness, until our familiar light bringer is only a shimmering, ghostly ring around a pitch-black orb. A total eclipse is occurring.
Nope.
This will soon be a reality. One is coming to the continent of North America in April 2024.
Pretty sure I saw that one.
If, like me, you are one of the many billions of people who won't get a chance to see that particular solar eclipse this April, you might be glad to know that America is not the only place they happen. And neither is Earth. Have you ever wondered what a solar eclipse looks like on another planet? Wonder no more. I'm Alex McColgan, and you're watching Astrum. And today, we're exploring solar eclipses, but not just the ones that happen here on this planet. Allow yourself today to feast your eyes on the actual images and even videos NASA has taken of spectacular eclipses from various places around the solar system. Firstly, I'll quickly explain some of the terminology to do with eclipses. A total solar eclipse is when an object moves in front of the sun, completely obscuring it, also known as an occultation of an object. This is the typical kind of eclipse we see on Earth when, at certain points in Earth's orbit, the orbit of the moon aligns with the sun. There is something special about an eclipse here on Earth. And I'm not just saying that out of some Earth-focused pride. By a bizarre but highly fortunate cosmic coincidence, the moon is the right size and distance from us that its angular diameter is almost identical in size and shape to the angular diameter of the sun in our sky. This leaves for an impressive spectacle where the corona of the sun, or in other words, the sun's upper atmosphere, creates a ghostly aura around the moon. This corona, normally too dim to see, extends for hundreds of thousands of kilometers into space. Looking closely around the edge of a total solar eclipse, you will also see the silhouette of the moon's craters along the outside, plus these reddish wisps coming off from the sun. These are prominences, millions of tons of charged particles suspended in the sun's atmosphere by powerful magnetic fields. During an eclipse here on Earth, the moon casts a shadow about 250 kilometers in diameter, which moves across the Earth as the moon orbits. In the case of the eclipse happening this April, this shadow will arrive at the Mexican west.
That's already over, so it's useless. What?
You don't have to be a VIP to get more than just savings with Geico. Every customer gets 24/7 fast-branded claim support.
Could I get a picture?
Yeah, it's not like you run into animal celebrities every day.
Stop! It's just the pug!
Get more than just savings, get more with Geico.
Ready to be inspired? Let's get
Did that person just say it's just a pug?
Design, antiques, and bespoke goods.
Motherfucker, that's not a pug. That's a fucking gecko.
Look at the
Planets of the solar system. It is my pleasure as your son to introduce our newest, fully formed, fully developed rocky planets. Now, if you would, please take a moment to introduce yourselves. Hey everyone, my name is Mercury, and mine's Venus.
Hello,
God damn, he sounds like a legitimate Fallout New Vegas ghoul.
some celestial bodies of the solar system. You may call me Thea.
Bruh.
I'm absolutely thrilled to meet each and every one of you, whether you're a rocky planet, a gas planet, or even a giant star. So, a little about me. My favorite hobby.
Anyways, I'm Earth, but you can call me Proto.
What? I'm like, wow, bro just went. Shut up. It's my time. I'm just gonna pause the video.
Okay. I mean, bummer, but okay.
Going back to your main idea, I love it.
You do?
Yeah, but forget about this one. I have a better idea. That's exactly what I mean.
Hey, Thea. I'm so sorry for being a bit cliquey. I hope you can forgive me, and we can be friends. Friends? Really? Come on, don't friend-zone yourself.
You've lost your tour, Thea. Your son will absolutely hate it.
Be persuasive. The question is, do you?
I love it, but it's not up to me. I just worry that the son will overreact if we tell him.
Okay, we can put it on hold. And speaking of the sun, I better go before he notices I'm out of my orbit.
Yeah, good call. I'll run a moon simulation using some asteroids from the belt.
And I'll continue my research to see if there's anything we've missed.
Oh shit.
See ya.
Yeah. Turns out, we're a bit off.
So my orbit, size, mass, and even the watery asteroids were not
Man, shut the fuck up.
Maybe I can ask Jupiter to give me one of his.
No.
But he has so many,
I think it's time to reopen my plan from
Come on, Thea, we talked about this. It sounds great, but...
No, I have all the right arguments. If I go to the sun...
The sun is a status quo paranoid. I'm sorry, but it's true.
Yeah, it's as if you don't want me to.
Don't finish that sentence.
Then I don't know what else to do.
You're the smart one. You know that?
And you pretend to be dumb.
I'm smart enough to know that you're going to figure this out, okay?
Okay. Thank you, Proto.
Okay, why do we keep doing that?
I mean, we did say we liked each other.
I know, but don't we know better already?
Yeah. I wonder if it means something.
Like what?
I don't know, but it's the one thing we're holding back from doing.
Only because we don't know the outcome. We could crash or merge or... I don't know.
Yeah, but everything that has a structure in the universe first came from chaos, which then took shape through gravity. The sun, the planets, the moons. I mean, even we came from a previous generation of dead rocky planets.
You're starting to scare me.
I say that love and gravity can be very similar, okay? That's all.
Love?
Generally speaking.
Right.
Anyways, the sun is...
Yeah, I get it. I'll see ya.
Yep. Bye, Proto.
Hey,
Hey, Venus.
how's the life project going?
Well, we reached a wall, but I have no idea how to demolish it or jump over it or, you know.
Maybe I can help.
Nah, don't want to trouble you with my issues, but thanks.
Can I be frank with you, Thea?
Yeah?
I feel like you've taken me for granted.
What?
I know I was a bit clingy and jealous, but you started your research on life with me, and I really cared about it. Maybe I'm not as smooth or as fun as Proto, but I was happy with the bare minimum of being your friend.
Venus,
If you think your issues don't matter to me, then you're not treating me as a friend. And if everything else fails, at least I want to be that.
you are absolutely right. I haven't been fair as a friend, and I'm sorry. I just assumed
Damn it.
others don't care about me or my dreams.
If that's how you think, then you're not being fair to those who do.
Are you sure you want to help?
Positive.
Okay, come. I need to orbit Proto.
Orbit Proto.
Become a double planet with him. Or a moon.
What? Come on, you're better than that.
Any prejudices you have on moons is entirely in your core, okay? This could solve our problems.
Like what?
Adjusting its tilt, which could create seasons.
Why do you need seasons?
Because life would need regular changes in temperature. But that's not all. I could also protect Proto from asteroid impacts, slow down his rotation, and a few other things.
Wasn't the plan for you to develop life? Suddenly it's all about Proto.
This can only work if Proto and I work together. It was never about it being me. It was about bringing life into the universe, whatever shape it takes.
How would you become Proto or its double planet?
Well, first off, I'd have to speak to the sun. But Proto is sure the sun would say no and keep us apart.
He thinks that.
Yep. So for now, the plan is on hold, and I'm supposed to figure out another way to develop life, which feels impossible.
Thea, do it.
What?
Proto is being paranoid. The sun also wants life in the universe, right? I believe with the right arguments, he could be persuaded.
That's what I said. But Proto thinks the sun loves his status quo.
He doesn't know the sun like I do. We're pretty close. You want to bring life to the universe? You have to take matters into your own hands. It's the only way.
I think you're right.
As I often am.
I'll go and explain to the sun my plan, and I'll use every argument I can think of.
Yeah, you do that.
Thank you, Venus. I will never take you for granted again. Wish me luck.
I'm sorry, Thea. I'm really sorry. Still trying to build a little moon, Proto? is. What makes you think this will be different?
I gotta do something, and we can always try something else.
By we, you mean you and Thea.
What's the matter now, Mars?
You've changed, dude. You used to not care about anything or anyone and just do your own thing. And then Thea comes and
The only thing Thea did is make me less afraid of something I wanted, which is to have life.
And you want all that responsibility for the rest of your existence?
Yes, it's the only thing that makes sense to me. I can't explain it either, Mars, but you better get used to it.
I don't see a happy ending in any of this. Thea, your orbit's that way.
I know.
So, why are you here?
I'm paying this on a visit. I have a fun little idea how I'm going.
I'd be careful if I were you. The sun tends to find a way to grab your idea and, like, twist it or get angry at it or...
It'll be fine. Ask Venus.
What did you do, Venus? None of your business, Mercury. Why was Thea headed towards the sun? She has some idea she wants to run by. Idea about what? It was for her own good. What have you done, Venus? Oh, hi, Thea. Long time no see.
We never quite finished our discussion about life.
Yeah, well, as long as everyone stays where they are, life should eventually just pop into existence. Right?
I'm doubtful.
What?
I've done some research, and you need to gather certain elements and conditions, and it's a long story.
Wait, you really leave in your orbit to do all of this? How come I never noticed?
No.
Drew and I have an idea.
What does he have to do with this?
Well, he's been helping me.
Thea here tells me you two have an idea.
Thea, why are we here? What's going on?
I wanted to discuss, you know.
What? No, Thea, don't!
Don't waste more of my time. Come on, spit it out.
Orbit Proto. Same with Pluto and Sharon.
What?
It's for a good reason, son. It's to develop life. If I change my orbit and go to his, we can
Change your orbit.
We can work together to develop life. Between Proto and I, we have everything we need. Please.
Thea, I am very disappointed in you. What? You know how many millions of years of planetary crashes I've had to deal with? How many planets like you two I've seen die over and over because they couldn't stay in their orbits?
Oh, come on. This is different.
Really? How so?
We know what we're doing, you big ball of plasma!
Is that really your best argument?
We love each other.
What?
At least I do. I know it sounds crazy, but I feel that us together may be the key to all this.
I love you too.
Really? You love me?
Are you surprised? Come on, I'm crazy about you, Thea.
No, no, no. I have to end this.
Oh shit.
Stay with me.
God damn. Oh.
delusions of love. I've got to protect everyone, including yourselves, so I'll do what I must.
What are you doing?
You two will stay in your orbits, opposite sides of each other, and I'll make sure it stays that way. And I don't want to hear anything else about your dangerous ideas, Leia.
Son, you're making a mistake. We are so close.
Close to causing more destruction, maybe.
No, to creating life. We all want the same thing. You do as well.
Stop.
I know you're afraid, son. You've gone through a lot. But I know deep in my core, this is the way. Proto and I can do it.
The oh shit.
You think I am afraid? Me?
Oh no, not the psychotic shit again.
Your light shows don't mean anything. Deep down, you want things to stay the same because you don't want to be alone anymore.
Yes, I don't want to be alone. I guess I know some things about this universe that you don't. You have the privilege of hope thanks to my light. But all I see is darkness. And you have to fear the dark, Thea, because it's all around us. And if you lower your guard, it will own you.
The fuck?
Never see each other again. This is as happy an ending as you'll ever get.
Several years later. Where the fuck did my one of my 3 piece go? Where did they go?
Hey, big guy. Hello, Mars. Nice to see you here. Yeah, so you're wise, right? I think so. I mean, yeah. So Proto Earth is my best friend, okay? And he's been in love with Thea for so long, and I thought now that the sun has separated them, he'll get over it. But no, he is miserable and mopey. Okay. And I try to cheer him up all the time. I throw asteroids at him, tell him jokes. Nothing works. What can I do? How can I get
It's called depression.
I thought all we wanted was to create life. I think the key point is that they wanted to create life. What's the difference? They are in love, Mars. They are going to fulfill their goals. It'll be together. So, if I want to be a good friend, I have to support him and go against the sun? I didn't say that. You've given me food for thought. Thank you, big guy. But Mars, wait. What's the worst that can happen?
Oh shit. Earth.
Don't think I don't know what you're doing, Proto Earth.
But we have to...
You and Thea can have no contact. End of story. Same goes for you.
Whatever you say, son.
Oh, don't give me that attitude.
Tell me, has anyone developed life yet?
No, but it's a matter of time. Now, go back to your orbiting around me. She doesn't want to talk to you, Venus. She hates you, so leave it be. Get what you had to. Hey! Hey! Let me go! Oh, Handy! You're finally awake! No, you are finally awake. I know, but after now what? I barely remember anything. I think I was cruising by this belt, and then cruising by the belt? Ah, you're so funny, Moon. sure? I feel like you're... come on! We need to introduce you to the sun ASAP!
Oh no.
Can we talk?
So, you finally decided to talk to me.
I know you hate me because I told you to speak to the sun, even if I knew it was a bad idea. At the moment, I thought I did it for your own good. But the truth is, I did it because I was jealous. And it was the only way to keep you two apart.
I know, Venus. I'm not gullible and stupid.
And I regret it.
Why? Because you didn't get me in the end?
No, because I took away someone that made you happy.
It's okay, Venus. I don't hate you. I just don't trust you.
Then tell me what to do. I'll do anything.
It's too late, Venus. You've had your chance to support me, and now we're past that. Sorry.
Hey, dude. Hey, Mars. I don't feel like playing asteroid dodgeball right now. I know. I want to talk to you about things. Please, now's not the best. We should fight more. What? I don't really know what you're feeling, but I know it means the universe to you. So, fight for it. I mean, I do miss playing asteroid dodgeball with my best friend, but this is bigger than me, dude. Mars.
Proto and Mars are too close. Hey, Mr. Sun. Oh, Neptune. Hi, I'm in the middle of Meet Triton. He's my moon. Wait, this one's new. Are you sure he's your moon? Or did you find it somewhere in the Kuiper Belt? No, Triton is my moon. I'm sure of it. Like, really? Really sure? Go.
Go where?
To Proto Earth. Go now that the sun's distracted.
Oh shit! Oh shit!
Wait, but Venus, how are we?
You'll know when you see him. You'll figure it out. You're the smartest planet in the solar system, Thea.
Venus,
I hope you find what you're looking for. And that you're happy.
I am 100% super mega positive that Triton is my moon. Cross my core and hope to succumb to the heat death of the universe. Neptune, what are we even doing? I'm presenting my arguments to the sun about why you are my moon. I don't know if saying the same thing over and over again counts as an argument. Wait, where's Thea? She's supposed to be over there. I don't know, but what I do know is that Triton is a trillion % my moon.
I want to be with Thea, but the sun won't allow us to even get close to...
Oh, who cares? Just follow your gut like you used to. Don't think, act.
I'm confused.
And you're doing it right.
Oh shit.
We'll play asteroid dodgeball again, Mars. I promise you. Go get the girl, dude.
What do you think you are doing? Don't you dare go back to your orbit. Hey!
What is going on?
I missed you, Thea.
I missed you too, Proto. Sorry if I've ruined everything.
Hey, it's not your fault. I think this is how things were meant to happen.
So, you have the same dream as I?
Yes, I know what we must do.
Me too. But, you know what this means?
Yeah, it's all clear now.
And you're not afraid?
No, because I'll do it with you.
Mother.
For blocking an editor. At last, this is only my supposition, assumption, and might not be true. If you know anything, don't forget to write down below.
The fucking mute. Jesus Christ, that's loud. Well, that was barely any information, but the rest is just a black screen, I guess.